the effect on the measure of dispersion when an outlier is added or removed from the set of data. The range will change dramatically when an outlier is added or removed from the set of data. The interquartile range is less affected when an outlier is added or removed from the set of data. Variance and the standard deviation will increase significantly when an outlier is added to the set of data. If the difference between the new value of the data and the mean is small, then the new standard deviation will be smaller and vice versa. If the difference between the value that is removed and the mean is small, then the new standard deviation will be larger and vice versa. The effect of data changes can be graphically displayed by using dot plot, stem and leaf plot, or box plot. So today we will focus on graphical representation for the effect of data changes. So the score of sign squeeze, when each value of a set of data is added by 2, so the score in sign squeeze shows the changes. Let's study the changes of the graph after added by 2. It is found that the whole dot plot is shifted to the right by 2 units, whereby the dispersion remains unchanged. Let's study the range. Original score range is 15 minus 8, which is 7. And the new range is 17 minus 10, which is 7. So the range of both graphs remain unchanged. So conclusion is when each value of a set of data is added by a constant, the measure of dispersion remains unchanged. Now let's study the case whereby we multiply by k, by a constant. Example k is 2. When each data is multiplied by 2, we will see the changes of the dot plot. So in the diagram, when each value of the data is multiplied by 2, we can observe that the dispersion of the whole graph becomes twice. Original range is 4, 5 minus 1, and the new range is 8, which is 10 minus 2. So the range of the new set of data becomes 2 times the range of the original data. The data is changed uniformly by multiplying or dividing by a constant. So score in mathematics quiz for the graph. When each value of a set of data is multiplied by 2, the score in mathematics quiz shows changes, as shown in the graph. In the above diagram, when each value of a set of data is multiplied by 2, it is found that the dispersion of the whole dot plot becomes twice as wide. Original score range is 5 minus 1, which is 4, and the new score range becomes 10 minus 2, which is 8. So the new score range becomes double. The range of the new set of data is 2 times the range of the original data. So when each value of a set of data is multiplied by a constant k, the new range is equal to k multiplied by original range. In general, when each value of a set of data is multiplied by a constant k, the measures of dispersion will change. When each value of a set of data is multiplied by a constant k, the new range is equal to k times original range. In general, when each value of a set of data is multiplied by a constant k, the measure of dispersion will change. The measure of dispersion of the new set of data become larger compared to the measure of dispersion of the original set of data when an outlier is added. The value added or removed is an outlier. The above graph shows that score in mathematics quiz, and the below one shows that the graph when an outlier is added into the data. Next, we'll learn that measure of dispersion of new set of data become larger compared to the measure of dispersion of the original set of data when an outlier is added. A value can be added or removed to the set of data, and the value is called as outlier. So what it means by outlier? Now let's study what happened to the graph when an outlier is added to the set of data. It is found that the dispersion of the whole dot plot become wider. Let's observe the range for original set of data and the new set of data. So the range for the original set of data is 5 minus 1, which is 4. So the new range is 9 minus 1, which is 8. So conclusion is the range of new set of data become larger when an outlier is added into the data. In the set above diagram, when an outlier is added into a set of data, it is number 1, the dispersion of the whole dot plot become wider. Original score range 5 minus 1, which is 4. New score range is 9 minus 1 equal to 8. So the range of the new set of data becomes larger compared to the range of the original set of data when an outlier is added. In general, the measure of dispersion of new set of data become larger compared to the measure of dispersion of the original set of data when an outlier is added. Let's see this example. Given a set of data 4, 6, 7, 7, 9, 11, 12, 12. Calculate the standard deviation of the set of data, and hence calculate the new standard deviation when 4 is removed. Okay, first of all, we need to find the mean. Okay, sum all the data divided by 8, so the mean is 8.5. So standard deviation, sum of data square over 8 minus mean square and square root 2.784. And the new mean now become 6 plus 7 plus 7 plus 9 plus 11 plus 12 plus 12 over 7. So the new mean become 9.143. Okay, the new standard deviation become 2.356. So when the value that has a greater difference from the mean is removed, the new standard deviation will be smaller. Okay. Okay, for question B, the new mean now is 4 plus 6 plus 7 plus 7 plus 7 plus 9 plus 11 plus 12 plus 12 over 9. So the new mean is 8.333. And new standard deviation now is 2.668. So when the value that is close to the mean is added, 7 is quite close to the mean. Okay, the new standard deviation will be smaller. So for C, new mean is 4 plus 6 plus 7 plus 7 plus 9 plus 11 plus 12 plus 12 plus 18 over 9. So the new mean now become 9.556 after added data 18. So the new standard deviation become 3.974. So when the value that has a greater difference from mean is added, the new standard deviation will be larger. 18 is very much greater than the mean, so the standard deviation will become larger. Okay, let's do it again for this question. You are asking to calculate the standard deviation of the set of data. Okay, after the outlier is removed or added. So the first step is we need to find the mean for the original data. So you sum up all the data divided by 8, so you get 8.5. And then you find the standard deviation. Okay, sum of data square over 8 minus mean square. So mean is 8.5. So sum of the data square divided by 8 minus 8.5 square, and you square root. Okay, your answer is 2.784. That is the standard deviation for the original data. Okay, let's say the number 4 is removed. So now the mean become 9.143, and the standard deviation also become 2.356. So the conclusion is when the value that has a greater difference from the mean is removed, 4 is different, very much different from the mean, 8.5. So the new standard deviation will be smaller. So just now, original standard deviation is 2.784. So the new standard deviation after 4 removed is 2.356 only. So becomes smaller. This is because the difference between the mean and 4, 8.5 minus 4, is 4.5. So it's considered very big difference. That's why the standard deviation becomes smaller. Now let's see what happens if 7 added into the data. Okay, so we'll find a new mean, you'll get 8.333. The new standard deviation is 2.668. So when the value that is close to the mean is added, the new standard deviation will be smaller. Okay, meaning that 7 is a number that is quite close to mean. Okay, the difference between the mean and the number added is 8.5 minus 7 is 1.5. 1.5 means that the value that we added is close to the mean. That's why the new standard deviation will be smaller. Now let's study the third case. We add 18. 18 is a number that is very far from mean. So we find the new mean, we get 9.556, and new standard deviation is 3.974. So when the value that has a greater difference from the mean is added, the new standard deviation will be larger, because 18 minus 8.5 is 9.5. That means there is a very big difference between the number 18 that you add, between number 18 and the mean. So that is why the new standard deviation will become larger. Original standard deviation is 2.784 and the new one is 3.974. Let's go through the notes again. What are the effects on the measure of dispersion when an outlier is added or removed from the set of data? So the range will change. Okay, the interquartile range is less affected. Then variance and standard deviation will increase significantly. Okay, students, please make sure you do all the homework. Please make sure you pass up your homework to my Gmail account. be a responsible learner. Okay, have a nice day. Bye.